So the counters now have like sine generation in them, so they can generate, each counter can generate 2 sines, and it can use them internally to perform math operations like Fourier transform on the fly. So you can now you can look at like IF frequencies, like let's see, that's kind of a low frequency. Let's make it higher.
So these are 2 different pins.
Yeah, and here's like 16 times the frequency. This is almost a megahertz, right? Yeah, the 2 different pins, and I'm changing the relative phase angle between them.
So what do you have connected to the I/O pin?
Anyway, what I got to do now is make it so, have it input and make sure that the input thing works, correctly, that it's getting it. But I got it all together. It seems to be working just fine.
Yeah, because I remember
well, you can change.
A few months ago you were showing me this when you were actually inputting and like digitizing and then re-outputting it, like trying to simulate the signal.
Yeah, take like, what it can also do, it can output a sine wave while inputting on the B, like it can output on the B pin and input on the A pin, and so that you'll be able to take like ultrasonic transducer,
yeah,
like a transmit and receive, drive the transmit with the reference output,
and still receive simultaneously on the input.
Yeah, with one counter. And so what you'll do is, as you move your hand like this, you'll see the angle. Like as you go further away, the magnitude becomes smaller, but the angle, when you get closer, it'll do this.
Oh wow!
You know what I mean? Because you're actually like winding against the phase.
Right. Oh, that's neat.
It'll make all sorts of cool stuff possible. Figure out where how it affects the phase over time. It'll be pretty cool. I mean, you could find like the resonant points of stuff.
So what does it do with the phase and the freak counter? Or the phase and the freak.
They're just used as normal. They set up the frequency of the sine wave. So the
for
top,
the output.
Yeah, and the input sensitivity. Because see, it's doing this lookup and this math to perform this sine. It's also taking like the raw number in and doing like a multiply by 1 or -1 based on the input bit at that time. And it's making separate cosine and sine accumulations. And in the end, you run those after like, I don't know, a millisecond or however long you want to wait. You run those things through the cortex system because they're X and Y points, and then that will do is it'll rotate it to 0. It'll tell you what X is, what the energy was, and then what the deflection angle was.
Okay.